The objective of this lesson is to simplify an expression by combining like terms. So let's start with some vocabulary words. The first one is a term, and a term is separated by a plus or a minus sign. So to understand the following vocabulary, we're going to take a look at this example here. And so if we want to list what the terms are, and they're separated by the plus or minus sign. So the 2x is a term, and the 5w, and remember, now that we've talked about negative and positives, we're going to look in front of the term to tell if it's negative or positive, the term. So that's a positive 5w, and then we have a negative 4x, and a positive 6, and a positive w. So those are all called terms. Okay, the next vocab word is coefficient. And your textbook sometimes refers to it as the numerical coefficient, but it means the number in front of the variable. In other words, the number that is being multiplied. Just like here we have a 2x, and 2 next to an x, we know that means multiply. So the coefficient is the number that's being multiplied to the variable. It's right in front of it, right next to it. So the 2x, the coefficient, is a 2. And then with the 5w, the coefficient there, the number in front here, is a 5. And then the negative 4x, it would be negative 4. But the 6 here doesn't have a variable next to it. It's not 6w, it's 6 plus w. So the 6 would not be a coefficient. It's not being multiplied by a variable. And then here with the w has a number in front of it. If there's not one there, it's an implied 1. Just like if you have a W, you have 1W. And we know that 1, if we had 1 and W was 4, 1 times 4 is itself. So if we put a 1 in front of a W, 1 times anything is itself. So that's why we're allowed to put a 1 there and not a 2 or a 3. So if there is no variable in front of the variable, or if there's no number in front of the variable, we think of it as a 1. So 1 is a coefficient. Okay, next let's talk about that 6 over here. This 6 had no variable being multiplied with it. It was just plus 6. So that 6 is what we call a constant. It has no variable next to it. So another example would be like x plus 3. The 3 would be a constant. Okay, the next vocab word, let's put this all together. We have to combine like terms. So what a like term is, it means that it has the same variable and exponent to be a like term. So if we look at our example up here, the 2x and the negative 4x, those are like terms because they both have the same variable and they both have the same exponent. It's an implied 1. Okay, then we have 5w and positive w. Those both have the same variables. So 5w and w. And the 6 has no like term with it. So those are our like terms. So now putting this all together, the overall picture here is if we were going to take this example here and combine the like terms, we would take the 2x and the negative 4x, and you would take the numbers and you would essentially solve this problem right here. And we could put these together because they have the same variable. So you would solve that as 2 minus 4. And 4 is bigger, so negative, and they're different, so we would subtract 4, take away 2, and we would get 2, and then bring the x with it. And then we could do the same thing with the 5w and the positive w. So we're allowed to combine these two together. And if we combine these two together, this would be 5, and this one would have essentially a 1 in front of it, and 5 plus 1 is 6W. And then this 6 right here has nothing to combine with, so we would just bring it down. So that's how we would combine the like terms and simplify to get this as our answer here. Now, when we write our final answers, it doesn't make it wrong if it's not in alphabetical order, but it would be much better instead if we put it in alphabetical order. So the reason why we like to write our answer in alphabetical order is so that everyone's matches and is the same. So instead of writing my answer this way, it's the same thing as if I take the 6W here and I put it first. And then I take the negative 2x and put it second. And then I put the 6 and I put the 6 at the end. And just like in the alphabet, W, X, Y, and Z, right? W comes before X in the alphabet, so that's why we would put the 6W first. Now again, this is correct, and so is this, but this is the best answer because it's in alphabetical order. It's the standard way we write our final answers. All right, so let's go ahead and practice all of this, and let's go ahead and write down Actually, before we start some problems here, let's make sure we understand why we can combine like terms. So to understand why this works, so what I'm saying is we could put these together. We could take the 2 and subtract 8 from it, and 8 is bigger. So we get 6, negative 6 because 8 is bigger and it's negative, and we would get negative 6x. That's what I'm telling you that we're allowed to do. But let's talk about why we can do that. So to prove it, let's pick whatever number we want. So I'm going to pick the number 2. And I'm going to take the 2x, and I'm going to take the x out, and I'm going to put this 2 in here. And then I'm going to take this 8x here and take the x out and put the 2 here. And I'm going to simplify this. So 2 times 2 is 4. And then here we have minus 16. And 4 minus 16, 16 is bigger, so negative 12. Now, if this really does simplify to this, then when I plug in that random number I picked, which was 2, and I do negative 6 and take the x out and put in the 2 like we picked here, then I should get the exact same thing here, because they simplify to the same number. So now that we understand that this works to combine the like terms, let's go ahead and do some examples of simplifying. So if we take a look at example 3, we can put these together. They both have x's. So we're going to solve 10 minus 7, which is 3, and then we get 3x. Take a look at example 4. These all have x's, so we can put them together. And so this is a positive 5 here. This is a negative 13 here. And this is a positive 1. So I essentially need to solve that arithmetic problem there. So if I'm solving this, I can do this in any order. So if I want to put the 5 here with the positive 1, they have the same sign, so I'm going to add them. So we get 6. And then 6 minus 13, 13 is bigger, so negative. And they're different. This is a positive number, and then we have a negative. So we subtract 13 minus 6, and we get negative 7. And they all had x's, so negative 7x. Okay, here we have x's and we have y's. So we can put this 14x with this positive 1 because they both have x's. So 14 plus 1 is 15x. And then we could put the 5y, positive 5, with the negative 2y, and we could solve 5 minus 2. So 5, because this one's positive 5, and this is a negative 2. So if we solve this, this is bigger, so we get positive. and they're different, so we subtract. So we get positive 3y. So this would be the best answer here because it's in alphabetical ABC order. But if you had 3y plus 15x, this is still correct, but it's just not in alphabetical order because x comes before y in the alphabet. Okay, here, if we start with the x's, there's no other x. So the 2x is just going to go in the front. And then the 3 and the negative 5, we have to solve that. 3 and negative 5. 5 is bigger, so negative. And they're different, so we subtract and we get 2. So our answer is 2x minus 2. So this is the correct best way to write our answer. However, if we did write it this way, where we put this negative 2 in the front, and then this positive 2x in the back, that is still correct, but this is the best way to write our answer because it follows the rule. And the rule is that we write our answers in alphabetical order, and the constant, the one without the variable, always goes last. Okay, here we have y plus y, and we could put those together because they both have y's. And remember the coefficient, the number in front here, if there's nothing there, it's always a 1. So we're going to solve 1 plus 1 is 2, and then we have the y come along, so we get 2y. Okay, example 8, these both have x's, so we could put this one and this one together. And so they don't have coefficients written there, so we know it's an implied 1. So if we solve 1 minus 1, we get 0x. And then that can be further simplified because when you have a number here next to a variable, that means 0 times x. And we know that any number, like 5 times 0 is 0. 4 times 0 is 0. So any number, because x represents a number, anything times 0 always equals 0. So our final answer is just 0. So we don't want to write it as 0x because that's not completely simplified, because 0x is 0. Okay, here we can combine the 4n and the negative 1n. So we would solve, this is 4 and this is negative 1, and those two would combine together to make 3n. And then we would put the negative 7 here, and then we have a positive 9. And we would solve that math fact there. 9 is bigger, so positive, and they're different, so we subtract. So we get 3n plus 2. Again, if you had this, it's still correct, but this is the better way to write it. Okay, here we can put the negative 7b and the positive 7b together. And since we have negative 7 plus 7, that makes 0. So this is going to cancel with this, and it's gone. So we do not write it as 0b. Because 0b is just 0. And we don't need to write the 0 down because we have a 3 here and a negative 10 here. So we're going to solve 3 and negative 10. And using our integer rules, 10 is bigger. So we look in front, and that tells us the answer is negative. And this is a positive 3, and we look at this as a negative 10. They're different, so we subtract. And we get negative 7. So we don't write it as 0 minus 7. We could, but then we would have to write that equals just negative 7. Alrighty, example 11 here. So here we have x's and y's, so the x's will go together. So we have 4x and negative 8x. So we're going to solve 4 minus 8 here, or combine a 4 with a negative 8. And 8 is bigger, so negative. They're different, so we subtract. And then we can put the positive 5y squared, so that's positive 5. And then we have a positive 4. and that would make positive 9y squared. So we do not do anything with these exponents here. And how do we know that? Well, if you did do something with it and you plug in a random number, it will not work. So we leave the exponent the same when we're combining like terms. And then this would be our final answer. Let's go ahead and take a look at example 12. Okay, so here we have terms that have ends. So because this one and this one have exponents, those ones go together because their exponents are both 2. And because this one and this term do not have an exponent of a 2, those two will go together. So now if you're wondering, well, which one do I put first if they all have the same variable there, they're all ends, well, it's just like with somebody that has the same name. So if someone's name was John Smith, and someone else's name was John Smith, how do we know who to put first in like a phone book? Well, if they have the same first name and last name, that's where the middle name comes in handy. So if this John Smith had Alex as the middle name, he would come before someone who had, let's say, Bryce as the middle name. So just like in a phone book, we have a rule to follow. The same thing with algebraic expressions. And the rule is the term with the higher exponent goes first. So when we combine these, we're going to put the positive n to the second power and the positive n to the second power, that answer when we combine those first. So remember that this is like a 1 here and this is a 1. So 1 plus 1 is 2. N to the second power, and then we're going to put the 6n and the negative 5n together, so we would solve 6 and negative 5. That would make positive 1n. Now we don't need to put a 1 there. We know that there is that 1 there. It's not wrong if you put it, but it is not necessary because 1 times n is just n. And then lastly, we can put the 3 and the negative 8 together, and we would solve 3 and negative 8. The 8 is bigger, so negative. And we would subtract because they are different, so we would get negative 5. So that would be our simplified expression. Okay, here we're going to combine section 1.8, which is the distributive property, with what we're learning in this lesson, which is combine the like terms. So when we have a problem like this, and we're trying to decide what goes first, think about order of operations, PEMDAS. Combining like terms and distributive property, the distributive property uses multiplication, whereas combining like terms uses addition or subtraction rules. So in a problem like this, we have to distribute first. So we know that if a number is in front of the parentheses, that we multiply it to what's in the parentheses. So here we would have 24, and then we would have 8 times negative 7b, which is negative 56b. And then over here, we would look in front. This is a positive 4, so we're going to distribute a positive 4. So we would have 4 times 2b, which is positive 8b. And then we would have positive 4 times 3, which is positive 12. So now that we have finished the multiplying, the distributive property, now we can add or subtract by combining the like terms. So we can put together the negative 56b and the positive 8b. So we would solve this math fact there, and we would know that 56 is larger, so negative, our our answer will be negative. And since they are different, we subtract and we get negative 48b. And then we can combine the positive 12 with the 24 and solve 24 plus 12 is positive 36. Since the 24 is bigger, we look in front of it and we know it's plus 36. Okay, with this example here, again, we have to distribute first, just like we talked about in the previous problem, why we do that. So we have negative 2 times x, and remember there's a 1 here, so negative 2 times 1 is negative 2x, and then we have a negative 2 times 5, which is negative 10. Now over here we need to be careful because this is not 3, we need to look at it as a negative 3. So we're going to do negative 3 times negative 2x, which is a positive 6x. And then we need to take the negative 3 and multiply it to, this is a negative 5 there, which is positive 15. Now we add and subtract so we can combine the like terms. These two both have x's, so we're going to solve by evaluating negative 2 and positive 6. 6 is bigger. They're different, so we subtract, so we get 4x. And then we can combine together the negative 10 and the positive 15, so negative 10 and positive 15. 15 is bigger, so we know we put a plus there, and they're different, so we subtract them, and we get positive 5. So our answer is 4x plus 5. Okay, here we're going to take the 5 and multiply it to the 2y. So 5 times 2y is 10y. And then we're going to take the 5 and multiply it to the negative 3. And get negative 15. And then here we have in front of the parenthesis here, there's something there. And if it's not a plus sign, we have to distribute it. So we're going to think of, just like we talked about the other day, that this symbol right here represents opposite. So when you have just a negative sitting right in front of a parenthesis like that, it changes what's inside the parenthesis to its opposite. So the 7y is now going to be a negative 7y, and the negative 2 is now going to be a positive 2. So that's what that does. By distributing it, it changes its signs. Okay, now we can combine the 10y with the negative 7y, and that makes 3y. And then we have a negative 15 and a positive 2. So negative 15 plus 2. 15's bigger, so minus. And then they're different, so we subtract. All right, last one here. So we have parentheses. We look right in front of it. And again, it's that negative symbol, so we have to distribute it. So when we distribute that symbol, it changes the 2x to a negative 2x and the positive 4 to a negative 4. And this 3 right here just gets brought down. And then there's no other x's, so we put that in front. And then we can combine the 3 with the negative 4, and 4 is bigger, so minus. And again, 3 minus 4 is just negative 1, so we put a minus 1 there. And I'd like you to add at the bottom of your page one last example here. So with this example here, we're going to take this negative 2 and multiply it to the 3x and to the negative 4 there. So negative 2 times 3 is negative 6x. Negative 2 times negative 4 is positive 8. Now here, in front of the parentheses, we need to distribute what it's in front of it. But when there's a plus sign, there's nothing to do. It does not mean to change what's in here to its opposite. So if it was a negative, then when we distribute it, it's going to make the 5x negative 5x and the negative 2 positive 2. But that is not what the plus sign is going to do. The plus sign has no meaning, so we just bring it down. And then the parentheses are not needed here, because when you distribute a positive times a positive here, you're just going to get a positive 5x. And when you distribute here a positive times a negative, it's just a negative 2. So when there's just a plus sign like that, there's nothing to distribute there. And then we combine our like terms, the negative 6x and the positive 5x. Negative 6 plus 5 is negative 1x. But remember, we don't need that 1 there, so we could just put negative x instead. And then we put the 8 with the negative 2 there. So 8 minus 2 is positive 6. So make sure that that problem goes at the bottom of your notes and make that number 17.